Hi everyone, welcome again to Last Minute Maths, and in this video we're going to be looking at the November 2021 Edexcel GCSE Maths Paper, Higher, and it's a calculator paper. Alright, so launching straight into it, let's see, first question. Alright, what we have is a scatter graph, and the information itself is not so important. Volume of traffic and carbon dioxide level. Monoxide, actually, sorry. Okay, so the first thing they're asking you to do with all these points is to find an outlier, all right? So an outlier. What an outlier is, basically, it does not fit the pattern of the rest of the points. So it's sort of like an anomaly. Okay, and in this one, just looking at the graph again, we can see it's that one there. All right, it's completely outside of the normal pattern and doesn't fit with the rest of the data at all. So that one is the outlier. We can see it's at 100 in terms of volume of traffic, number of cars, and 18 in terms of the carbon monoxide level, milligrams per cubic meter. So all you need to put in is the 118 there, 100,18. And then it's saying for another day, 370 cars pass the point on the road, and it says estimate the carbon monoxide level for this day. So it's an estimate. That means that they're looking for a value within a sensible range. In order to do this, you need to first draw a line of best fit. All right, so what I've done there, line of best fit, and it's just a question of taking a ruler and positioning it. You can see that there are a range of lines that you could draw. Remember, it must go through the origin, because when you have 0 cars, we make the assumption that there will be no carbon monoxide floating around due to the cars. Okay, so making that assumption, you could, one extreme is go somewhere like that, right? Or the lowest possible gradient, slope, somewhere like that, okay? So somewhere in between, I've gone for so like a medium range there, and I've drawn a line of best fit, and on that, I'm reading off 370 cars, and going up, looking at where the line crosses that value, something in the region of 14, so that's 15, and let's say 15 and a half. Yeah, thereabouts. Okay, and right, just moving back. Yeah, I've read off 15 as my value, as an approximate, right, as an estimate. You could, I suppose, go in the range of somewhere between 14 and 16 would be quite acceptable. So if you look at that range there, like that. All right. Rest of that, I think, is probably self-explanatory. Okay. And then the next part of the question, statement. Alfie says, because there is an outlier, there is no correlation. Okay. In order to understand what correlation is, correlation means that there's some relationship between the two variables. So pattern between the variables, all right? Okay, and in this particular case, just to highlight, there are different types of correlation. In a graph which has that, so the value, as one value increases, the other increases, that's called positive correlation. And something like that. As one value goes up, the other one goes down. That's negative correlation. And if you had, for example, things scattered all over the place like that, right? That's no correlation, zero correlation. So in this case, the question is asking, is alpha correct? And the answer is no. The majority of the points show positive correlation. They all do fit a pattern. There's just one that is an outlier. So in this case, we will say there is positive correlation. All right. Okay, question 2. Right. Natalie makes potato cakes in a restaurant, and it's got 3 ingredients: potato, cheese, and onion. And the weight of the various ingredients are given in that ratio 9, 2, and 1. So in total, you've got 12 parts. All right. So Natalie needs to make 6,000 grams of potato cakes. And we're told that cheese costs £2.25 for a 175 gram packet, block, whatever it might be. And they want to work out the cost of the cheese for this particular amount, so 6,000 grams of potato cakes. So the first thing we've done, obviously just restated the question. We know there's 12 parts, and therefore the 6,000 grams has to be divided by 12, right there, to say that each part is worth 500 grams. All right. Therefore, the amount of each ingredient. Now, this step, you don't need to do all of it. What we actually need is a cheese. So there's a cheese bit there. Okay. So the amount of cheese, because it's 2 parts, therefore 500 grams per part, 2 times 500 equals 1,000 grams. So a kilogram of cheese. All right. Now, one thing we have to do is to assume that the cheese is sold in 175 gram blocks. All right. Not loose per gram or etc. So if we make that assumption, and it's better to write that into the answer itself, then for 1,000 grams divided by 175, we're going to need 5.7 packets or blocks, whatever the case may be, and therefore it's 6. All right. And so the cost of 6 of these packets or blocks, £2.25 each, comes out to be £13.50. So there's your answer there. Right. Hopefully that's self-explanatory. And next one to do with standard form. All right. Standard form. And they've given us a number, 4.5 times 10 to the power 5. Okay. So in order to make that into a normal number, we want to get rid of the 10 to the power 5. That means moving the decimal place 1, 2, 3, 4, 5 places to the right. Okay, and that gives us 450,000 as total. All right. Now, in the second one, we're going from an ordinary number to a standard form number. And remember that the base number, this one here, the 7, right, must be between 1 and 10, i.e. less than 10. Okay, so all we're doing here now is moving the decimal place from, or rather, we've moved the decimal place from behind the 0 here, the first 0, all right, and we want to move it the other way. So effectively, we would have started with 7 and then 3 moves of the decimal place. So that becomes 10 to the minus 3. Or 7 times 10 to the minus 3. Okay. Right, next one. Now in this one, because look, the powers are different, right? They want us to add two numbers which are of different powers of 10. So in this case, we need to change the numbers to ordinary numbers. So 4.2 times 10 to the 3, move the decimal place 3 times, and you get 4,200. And the 5.3, we move the decimal place twice, and that makes it 530. And then just plain addition, all right, not too difficult. Then we need to work out the decimal place for the standard form, 2, 3. So we're moving the decimal place 3 to the left here, right? And so that is 4.73 times 10 to the power 3. All right, so that's your answer there. Right, number 4. Okay, a water tank starts off empty, as we can see, and Anil needs to fill the tank with 2,400 liters of water. Okay, and there were 2 companies. So you've got company A and company B. And they've given us a conversion of 1 gallon equals 4.54 liters. So they're saying that company A would take more time to fill the tank than company B, all right? And what they're looking for is the difference in times, all right? And it's to the nearest minute they want. Okay, tackling this question, we need to convert the rates to the same units, all right? Liters per minute is what we want. So for company A, just reminding ourselves of the value, it's 8 liters in 1 minute 40. So 1 minute 40 actually is 100. Yeah, hang on. 100 seconds. All right. And the 2.2 is simply per minute. So that's already in the right units. So what we're doing is that we know we can get 8 liters in 100 seconds, right? And we want how many would we have in 60 seconds, all right? So that's 60 over 100 times 8. So that actually gives us 4.8 liters per minute for company A. The calculation for B is that we know it's 2.2 gallons there, and each gallon is 4.54. So company B is actually supplying 9.988. I've kept the extra decimal just to keep the calculation as accurate as possible. And that's almost 10 liters per minute. All right. So now we work out the times, and we know that the amount that we need is 2,400 divided by 4.8 equals 500 minutes, right, on the dot. B, 2,400 again, and this time 9.988 liters per minute. So the number of minutes is about 240.288. Right, not worrying too much about the decimals at this point, but the difference in time, therefore, is the 500 minus the 240, and when you've rounded things down a little bit, you're you're getting to the nearest minute 260 minutes difference between the two suppliers. Hopefully that's made sense. Right, number 5. This one's a little bit of an interesting one. There's a sequence of numbers, and you can see what they are. A, 2A, 3A, 5A, 8A. This is actually what the Fibonacci is. The Fibonacci is made up of the sum, like this thing here, the sum of the previous 2 terms, all right? So you're starting with A, and then the second one is just 2a, right? The third one, the 3a, is made up of a plus 2a, okay? In a real Fibonacci, it actually comes as 1, 1, 2, 3, etc. In this particular one, it sort of skipped out the first a. All right. So what they're asking for is the sum of the first 5 terms of this sequence is 288. Using the values that they've given, the first 5, the next one is actually 8a, which is the 3a plus the 5a, all right? And therefore, the sum of the first 5 is a plus 2a plus 3a, which comes to 6a plus 5a, etc., plus the 8 is 19a, all right, what we have here, equals 228, and therefore a equals 12. All right, not too difficult, that one. Okay, number 6. In a bag, there are only red counters, blue counters, and green counters, and then pink as well, just for good measure. Now, what they've done is given a probability for the red and the blue in decimals. All right, so 0.05 probability of getting a red and 0.15 of getting a blue. They then give us more information that the chance of taking a green counter is 0.2 more, right, than the probability of taking a pink counter. And straight away, we need to set up an algebraic expression. So what I've done is that the green plus the pink must equal, right, whatever's remaining from 1. Because remember, the most important thing, when you only have 4 outcomes, the total must equal 1. All right. So all probabilities in a given event must add up to 1. So if we know the red and the blue, then the green and the pink together must be 1 take away whatever there is for the red and the blue. All right. The red and the blue together equals 0.2. And therefore green plus pink must be 1 minus 0.2, and that's 0.8. We then know that the green is the pink probability plus 0.2, all right? So substituting that, we know that if we convert that into G plus P must equal 0.8, and substitute the G into there, then we get 2p plus 0.2 must be 0.8, and therefore p is 0.3, and G equals 0.5, all right? And that's what we put back into the table. Again, if there are any questions, or if you're not sure about a particular solution, if you're watching, please do leave it in the comment, and I'll be very happy to put a solution back in the reply, or do another short little 2-minute video just to explain something in more detail. You're all very welcome to do that. Right, and then next part of the question, there are 18 blue counters in the bag. All right, work out the total number of counters in the bag. The blue, if we remind ourselves, has a probability of 0.15. So the 18 must represent, and I'll write this out here, 18 over the total must represent 0.15, okay? And that's what I've done in that statement there. And therefore, the total equals 18 divided by 0.15, and that gives us the 120. All right, hopefully that's clear. Right, next question, 7. And this one's one area of shapes and so on. And let's see how we tackle this one. We want this shaded region, okay, in there. And notice that we have 2 different shapes. we've got a triangle, and we've got, all right, not the most accurate little sketch, but there you go. You've got two different shapes there, and this represents the difference. The shaded area we're asked to find is the difference between two shapes. One's a triangle and one is a quarter circle. All right, the quarter circle is effectively called a sector. All right, and so we're going to work out these two shapes, the area of these two shapes first, and then find the difference between them. So the area of the triangle ORP is simply half times base times height. And we can see from the diagram that we've got 8 is the base, if you were to turn it around, and the height is also 8 because it's a right angle triangle. All right. And so half times 8 times 8, 32. Now the area of the sector, right, we have to take it as a fraction of a circle. And because the sector has 90 degrees, right, we put 90 over 360. 360 is a full circle. Okay, so 90 over 60 times the area of a circle, right, and the radius of this particular circle is 8. So pi times 8 squared, that's 64 pi, and 90 over 360 is a quarter. So there we have effectively 16 pi is the area of the sector. So the segment, the shaded area is actually a segment. That has area 16 pi minus the 32 of the triangle. Okay, and remember the question says 3 significant figures. So when you put in your calculator, you're getting 18.265, etc. And we're going to cut it at the 3SF, and therefore it becomes 18.3. All right, because the next number after the 2 is 6, rounded up, 18.3. And the units are square centimeters. All right, hopefully that is clear. Now we've got a sketch thing with proportionality. Y is directly proportional to X, it says. All right, so Y is proportional to X, and we can replace the proportional sign with a equals K times. So Y is effectively some number times X. All right, and sketching that is just a straight line. Nice and simple. And it must go through the origin. All right, because when X, according to this, when X is 0, Y must be 0. The next one is Y is inversely proportional. All right, inversely proportional means 1 over something. Okay, the proper word for it is reciprocal. But as long as you remember inversely proportional, it's basically whatever is here and whatever is here, right? You put 1 over that, like that. Okay, so Y is inversely proportional to X, and therefore Y equals K over X. And what this shows us is that whatever K is, as X gets larger, because K is a constant, as X gets larger, you're dividing a fixed number by a larger and larger number. So Y is going to become smaller. And that's what gives you the graph that I've sketched there. All right. It's basically a 1 over X graph. All right. Next one, number 9. What we have here is like a comparison. So Monday, 12 people took 5 hours to clean a number of cars. All right. And on Tuesday, 15 people cleaned the same number of cars. and they want us to work out how long that might take. All right. With this question, always use totals. Right? What I mean by that is that 12 people working for 5 hours is a total of 60 hours. All right. And so if you then have 15 people working on the second day, then those 60 hours of work divided by 15 people, it's going to be 4 hours. All right. Now, the assumption they're saying, right, that they've said, assuming that all people are working at the same rate, the assumption is wrong, it says. How might this affect the time taken for the 15 people to clean the cars? Well, if they do not work at the same rate, the time taken could be longer or shorter. It's a bit of a non-question, really, but that's what they want, and that's all you have to say, that it's not going to be a straightforward calculation. It can be either way. Right, question 10. Okay, this one is perhaps simpler than it actually looks, and the principle here is similar triangles. And ratios, right? All to do with ratios. Got it. All right. So we are given this information. A to D is 9. And D to B is 6. And then there's C to B, which we are going to find out. And in the middle, you've got this vertical bit, DE, which is 2. All right. So they want the what I've labeled as X, the total distance from C to B. All right. Let's start off with some basic Pythagoras, because remember we have right angle triangles here. Okay. Both the big triangle and the small triangle are right angled. So Pythagoras is valid. All right. So what we're using to find EB first, that one there. So EB squared, right, must equal 6 squared minus 2 squared. It's a minus because we know the longest side is 6, and we know one of the short sides, that is. So minus, and that comes to be 32. All right. If you then use square root of that, you can, in your calculator, put it in decimals if you wish, if you prefer that. Okay, I've chosen to leave it in surd form. That's 4 root 2. Okay, because you have square root. I'm just going to remind you of surds here, actually. It's a good opportunity. Root 32 is the same as square root of 16 times 2, and therefore that is square root of 16 times square root of 2, and therefore 4 times root 2. All right. As I said, you can use the decimal calculation right at the beginning if you prefer. Now, if we have similar triangles, we can see that X over EB, so in other words, I'm going to write this out here, CB over EB, in other words, the total length over the starting the shorter value, EB, must be the same as the total hypotenuse. All right, actually, you know what, let me just do that. Change my mind. I'll write that as a full calculation. So AB over DB. Okay, so using that, we get the ratios, proportions here. X over 4 root 2 must equal 15 over 6. And rearrange that. Okay, just multiply the 15 over 6 by the 4 root 2, and you get 14.1421, etc. And again, I've cut the number after the second decimal, 14.14. All right. So if you're not quite sure of the similar triangle method, then do take a look at that. And again, if you need some clarification, please leave it in the comments. Number 11. Okay. This is perhaps a little simple for a calculator paper. It doesn't require any calculation. Freya, it says, writes down the value of x correct to 1 decimal place. All right. So that means it's been rounded to just 1 decimal place, which is 6.4. So the 0.4 is the decimal place. And therefore, the maximum that number could have been is 6.45. The upper, that remember, is the upper bound. And the lowest it could have been, that could still round to 6.4, would be 6.35. And that's the lower bound. All right. So just put those numbers in. And, there's nothing complicated about that. But do notice, if you're doing it in another question without the answer format given to you, remember that the upper bound is a less than, not less than or equal to. Something important to watch out for. Okay, just as a note. All right, moving forward, number 12. Now we've got what looks to be a bit of a scary set of powers and numbers, etc. Right, the trick here is to treat the number value and the x variable separately. Okay, you can actually deal with them separately. And taking one at a time, let's look at the x first. On the left-hand side and on the right, we know that we've got x to the power 6 to the power 1 over n ends up as x to the power 3. All right. So remember the rule that a to the power, b all to the power c must equal a to the power bc. You multiply the powers. So 6 times 1 over n becomes 6 over n. And if these powers are equal, then 6 over n must equal 3, and therefore n equals 2. That's the first thing. The other side of it, the whole number, right, the 7, must be 1 over n, so a to the power 1 over n. So a to the power 1 over n. We've worked out that n equals 2. Therefore, a to the power 1 over 2 equals 7, right? And that, the power 1 over 2 is effectively square root of a. Square root of a equals 7. Therefore, a must equal 7 squared, right? And therefore, that's 49. And there you have your answers there. All right. 13. What we have here is one of those typical questions with a set of shapes put together. The rectangles are identical, all right, bear that in mind. And therefore, what we're going to do is label the long side of the rectangle A and the short side of the rectangle B, okay? Now, we are given coordinates of this corner here, right, B, with coordinates 11, 20, and our starting point A, right, that corner there, is 3, 4. So what we can see is that those are the only numbers that we have, and we're going from there, i.e. horizontally, up to there, and vertically from there to there. So dealing with the horizontal first, we can see that we're going 2 long sides across, but the corner B is on the top left side. So the expression we get for that is that 2a minus b, all right? So the distance across for point B is 2a minus b, and that must be the difference between the x's, all right? So difference in x values. All right, and that therefore gives us an equation 2a minus b equals 8. Applying the same thing for the vertical, we know we've got a b at the bottom there, and then 2a's, all right? Let's see, there's an a there, and another a there, all right? So it's 2a plus b must be the y difference. Okay, and that's 20 minus 4, all right? So that gives us 2a plus b equals 16, all right? So effectively you've got simultaneous equations. All right, and the best way of cancelling something out and simplifying them is add them. So effectively the minus b and the plus b will cancel out. Yeah, that equals 0. So 2a plus 2a, 4a, and 8 plus 16, 24. And therefore simple answer, a equals 6. And using either of those equations, so for example the first one, 2a 12 minus b equals 8, so b must be 4, all right? And therefore, the values we've got for, going back up to the diagram, for c, we can see that it's going a across on the x-axis, so that's 3 plus a, that's 3 plus 6 equals 9, and on the y-axis, it's going up just 1. So the short side, that's b. So this one is 4 plus b, and that gives us 8. All right? So that basically is working out simultaneous equations derived from a graph and the shapes. Right, this next question, number 14, I think is possibly one of the most difficult questions on this whole paper. So pay particular attention to this technique. It's can be tackled different ways. I've chosen one particular way, and if you have a different idea or feel you have a better method, then please do, again, leave it in the comments if you want. All right, we have a lot of information in this question to put together and take it one step at a time. The first thing we're doing is that Fran and Gary, together, they share whatever suites they have in the ratio 2 to 3. So their total, if you like, is 5 parts. All right. Olivia and Jessica, O and J, and they share their suites in a 9 to 1 ratio. So their total is in 10 parts. All right. They've then given us this whole kind of set of labelings. Fran gets W, Gary got X, Olivia got Y, and Jessica got Z, etc. So the total is the sum of all of those parts. All right. Now let's tackle the whole bit of information step by step, as I said earlier. And the bit that we're going to use first is the fact that Olivia and Jessica have in total half as many suites as Fran and Gary. All right. So that means Olivia and Jessica, their total equals half times whatever Fran and Gary have. Okay. I've now replaced it with the variables for each one. So remember, Fran is W, Gary is X, Olivia is Y, and Jessica is Z. All right, straightforward. Put it all in there. And what I've chosen to do, right, because Fran is first on their list, just randomly, I'm going to work in terms of W. I want to get everything in terms of W, i.e. Fran's suites. So starting first of all, we know that the W plus X, in other words, Fran and Gary, their suites, whatever their total is split on a 2-to-3 ratio, all right, as you can see here. All right. And when you cross multiply that, you effectively can get x equals 3 over 2w. So Gary is getting 1.5 times whatever Fran has. Okay, so I can replace the x's with 3 over 2w, right? That value there. So w plus x is the same as w plus 3 over 2w, and therefore the total number of suites on the right-hand side, i.e. Fran and Gary put together, represents 5 over 2w, i.e. total of 2.5 times Fran's suites. So that's the first step. Then we do exactly the same thing for Olivia and Jessica, all right? So y and z. So we know that the total is split 9 to 1. Therefore, y must equal 9 times z. All right? So we can replace the y's wherever we see it with 9z. Therefore, in total, 10z. Okay? So what we've done, right, bear in mind, is taken this whole statement here and brought it down to that there, all right? So 10z equals half of the total for Fran and Gary, all right? Tidying this up, 5 over 4, and then there's a 10 on this side, okay, here. So tidying up all that algebra, okay, it's simply the number of suites in Z, all right, which, as we remember, is Jessica, all right, is 5 over 40 of whatever Fran has, okay, and that's 1/8, right, 1/8 of W, okay, and so we know what Z is in terms of W, you got that? Then we can apply that using all the ratios and things that we worked out so far, that Y is, remember, 9 times whatever Z was, okay? And so Y must be 9/8 of W. X, going back to the beginning, we already know is 3 over 2W, okay? And W is just W, whatever Fran has. So what we've done is taken all of those three and put them in a set of ratios in exactly the fraction form that we found them in. So 1 to 3 over 2 to 9 over 8 to 1 over 8. Okay? And the best thing to do is multiply everything by 8. And that gives us whole numbers. So it's 8, 12, 9, and 1. So that's the ratio of the suites for each person. Okay? That, I feel, is the most difficult one on this paper, really, in terms of putting all that information into some sort of a recognizable algebra form. Again, any questions, please feel free to leave that below in the comments. Okay, this next one, number 15. Graph gives the volume of water in liters in a container at time t seconds after the water started to flow out of the container. So obviously the graph is going to be going downwards because the water is flowing out. And what they've asked for, work out an estimate for the rate at which the water is flowing out of the container at t equals 12. All right. Whenever you have a rate, that means a gradient, i.e. the slope. Okay. And they've said it's an estimate because in this case, what you have to do, exactly as I've done, is draw a tangent. Okay, and the base point for that is 12, all right? Yeah, so the point here is that you can only use a ruler and make like a best guess in terms of like judging where it touches a graph and what slope to take. And what I usually do is when I put the ruler there, I try to just visually, by eye, take a look at the distances on equal sides there and try and make that roughly balanced. All right. Obviously, there's going to be a little variation, and as long as your answer is at a reasonable level within the range that they're expecting, then that is acceptable. That's why it's called an estimate. All right. Okay, so what we're taking for the gradient is obviously the y difference over the x difference. So the change vertically is, I'm reading it as being 28 down to 0, all right? And the time, my graph just happened to come out at 30 seconds. So I've got 28, and I've put a minus there just to show that it is actually a negative gradient, but they don't actually bother much about that in the mark scheme, if I remember correctly. So 28 over 30 in your calculator, it in proper maths will come out as minus 0.93 liters per second. And you can just say that the rate of change is 0.93. And yes, you can put a minus there. All right, I think I forgot that when I wrote the answer. The reason you can get away without the minus is that they're already saying it's flowing out. So therefore it's understood that the direction of the change is negative. All right, you can do either, it'll still be correct. All right, number 16. This one, we've got a curve, has an equation with y equals x squared plus 3x minus 3. So that is a quadratic. And then there's a line which has equation y minus 5x plus 4. Now, I've rearranged it into the form that most of you will recognize, mx plus c, all right? So the one that we want to work with is y equals 5x minus 4. Okay, and it says show algebraically, all right, no graphs. It's got to be done mathematically through algebra, that they have exactly 1 point in common, meaning it's got one intersection only. Okay, so the first thing we do to find a point of intersection is we're going to equate the two graphs, the two y values. Okay, effectively we're saying y1 equals y2. So x squared plus 3x minus 3 equals 5x minus 4. Bring everything to the other side, all right? And as you can see, I've changed the sign, so it becomes minus 5x on the left-hand side and plus 4 on the left-hand side. Tidy all that up, collect up your like terms, and we end up with x squared minus 2x plus 1. And hopefully you can recognize that is of the form x plus a squared, which is x squared plus 2ax plus a squared. All right. And this turns out to be, and whether it's plus or minus, it's the same thing. All right. Exactly the same rule. And that will give you a pair of solutions, effectively x minus 1 squared. All right. And equals 0. So therefore, x can only equal 1. And therefore, y also equals 1 when you put it back into the second equation, let's say the line. So 5 times x, 5 times 1, minus 4 equals 1. So that gives you y equals 1. And there are no other solutions, all right? And just for completeness, I'm going to put down that second version, just in case the minus sign confuses anybody. And that's x squared minus 2ax plus a squared again. All right. Okay. So those are the solutions given there. And I'm going to go back just 1 second. I think I should suggest writing into the solution only one coordinate possible. It's worth writing that in. Okay, next one, number 17. Right, we're back to the proportionality. So these are all the proportions questions, or proportionality question if you wish. All right, and again, a little more complex than that they've had in the last 2 or 3 years of exams. So we've got two statements here, x relating to y, and then y relating to z, okay? And they want a formula for x in terms of z. So they want to get rid of y in the middle. And they've given us a particular set of values to use at the end. All right, so what we're going to do, x is proportional to y squared. You remember in the earlier question with sketching the graphs, you can replace the proportionality sign with equals k times whatever you have. So therefore we get x equals, and I've labeled it k1 times y squared, right? To make sure we have two different equations and we're not mixing the constants, all right? And on this side, using exactly the same logic, y is proportional to cube of z, so z cubed, and therefore y equals k2 times z cubed, all right? So what we can do now is to replace the y in the first one with an expression for y from the second equation. So you can see what I've done there is that x equals k1 times y squared. Now y is k2z cubed, so we're going to put k2z cubed in brackets and square the whole thing, and that gets rid of the y between the two equations, all right? And we're going to replace the k1 times k2 squared, all right, with just another letter. Let's call it a. So it's one combined constant, okay? And remember again that z cubed, all to the power 2, you multiply the powers, and therefore you get z to the power 6. So with everything done, we end up with this equation that is x equals a constant times z to the power 6. We then substitute the numbers that they gave us, right? Z equals 2, x equals 32. Put those in, and we get 32 equals a constant times 64, and therefore the constant turns out to be a half. And putting that back into the equation here, we get x equals half times z to the power 6, or you can write it as z to the power 6 over 2, right? Whichever takes your preference. Both answers are correct. All right, so there we are. Number 18, vectors, okay? Now, with this one, they've given us some information. So we know that OA is vector A, O to C is vector 3b, all right? And then they've given us A to B is just the vector B, all right? And that tells us, obviously, A to B and O to C, i.e. the top and bottom of this big trapezium, are both parallel, all right? Then they've given us some ratios. So D, this point here, all right, so there is such that O to D and D to B, 2 to 3. So I've labeled that on the graph, all right? And then B to E and E to C, 1 to 4, All right, again labeled on the sketch. Sorry. Okay, what they want us to do is to work out the vector DE. All right, so DE, this is the one that we want. Okay, in terms of A and B. Okay, we're going to start by structuring this one step at a time and breaking it down. First thing we want is OB. Right? And OB is simply going up to OA, right? So that's OA plus AB, all right? So just A plus B. Therefore, from there, we work out that OD, right, must be 2/5, because remember it's a ratio of 2 to 3, so the total equals 5. So O to D must be 2/5 of OB, right? And DB, therefore, must be 3/5 of OB, all right? So if one of them is 2/5, the other one must be 3/5. All right, so we've got the DB element. Next thing we want is B to C, all right? And that one is effectively taking a root which goes, let me just put that here. So B A plus AO plus OC. So that's minus B minus A plus 3B. All right. And that all comes to 2B minus A. All right. And B to E, again, using the ratio. Again, it's a 5. All right. So B to E must be 1/5 of the total of B to C. All right. So just hold that result there for a moment. And the thing that they've asked us for, DE, all right, sliding down again, D to E must be the same as D to B. So we're going to go that way and then that way, all right? So D to B plus B to E, and we've worked out all these elements. So we've got the two vectors that we want earlier on. So DB, 3/5 of OB, plus 1/5 of BC. Now replacing the OB and the BC with the correct values of A and B, you can see that we have these results. AB there and 2B minus A. Tidy all that out, all right? Just an example. So 3/5 of A plus, minus, let me correct that. Apologies, small mistake there. Minus 1/5 of A from the second brackets, and you get 2/5 of A. And then also 3/5 of B plus 2/5 of B gives us 5/5 of B, which is just B. All right, hence the answer there. Right, I hope that made sense. Okay, number 19. All right, and this is one of those growth questions, and it also uses another thing called iteration. Okay. At the start of year N, to the first year, the number of animals in a population is Pn. All right. So Pn, the little n there, means the population in whatever that number is that particular year. All right. At the start of the following year, which obviously must be n plus 1, the number of animals in the population is Pn plus 1, and we know that the population of each year is some constant times the population of the previous year. So to try and work that out, they've given us two sets of data. One for 2017, all right, there. The number of animals in the population was 4,000. And then 2019, the number of animals in the population was 3,600. All right. So they want us to find what K is. What we're doing here then is using the formula they've given us for the 3 years in question. All right. So you got 2017 is simply a starting point, 4,000. Then 2018 must be k times the previous year's total, which is k times the 4,000. All right. And then 2019 is whatever P 2018 was times k again. All right. So that actually tells us that P 2019 was k times 4,000. So basically k squared times 4,000, as you can see there. And therefore k squared, rearranging it, is 3,610 over 4,000 equals 0.9025 in your calculator, exactly. All right. And then square rooting that, okay, because you had a k squared there, square rooting that, you get 0.95. So k equals 0.95. All right. Number 20. This possibly the second hardest question on the paper. All right. Looks really harmless and it's only 2 marks, but you need to know your probability methods for this. All right. So probabilities. And it's the second time in this paper that they actually use the result that all the outcomes in an event add up to 1, and that you have to take away what you don't want. All right, so rather than adding up all the probabilities, you take away the couple that you don't want, and whatever you're left with is what you want. All right, so if you're not sure on that particular method, please go back and look at it again, or again drop it in the comments, and I will happily do a video on that. Right, so Pat throws a fair coin n times. Okay, find an expression in terms of n for the probability that Pat gets at least 1 head and at least 1 tail in those n times. Now, because it's n times, you cannot work out all the different possibilities and all the different events that could happen. What you have to do is to work backwards. All right. If we want at least 1 head and at least 1 tail, the 2 outcomes that we do not want, as I've said here, all right, the 2 results we do not want are all heads and indeed all tails, right? So we can't have that or that. So if you had all heads, straightforward, it's a half to the power n, however many times you're tossing the coin. And then with tails, again, it's half to the power n. So adding those 2, you get 2 times half to the power n. Okay. The reason this looks actually much simpler than it is because both heads and tails have the same probability. All right, that's why it perhaps doesn't look any different in terms of solutions, but that is the correct way to do that. And therefore, all others are acceptable. So just get rid of these 2. So 1 minus 2 times half to the power n, okay? And that is your actual solution. All right. Any confusion, please do ask in the comments. Number 21. Speed time graph showing the speed in meters per second of an object t seconds after it started to move from rest. All right. And notice that the speed is not constant. It's changing as we go along. And it says, using 3 trapeziums. I can't resist. I have to change this. Trapezia. All right, for correctness. Anyway, don't mind me. I'm a little picky about that. All right, using 3 trapezia of equal width. All right. Work out an estimate for the area under the graph between t equals 1 and t equals 4. All right. You've seen on the graph, I've actually done my 3 different trapezia, and you've got A, B, and C. Okay. Each of those I've just connected. You can see up here, right, to create a trapezium in each case. So remind ourselves that the area of a trapezium is given by the sum of the top and bottom lengths of the trapezium divided by 2 times the height, all right? And so for trapezium A, the height of the top, if you like, is 4, and the height of the bottom is 6. Add those two, so you can see there, divide by 2, and then times by the width. The width in each case is just 1, all right? So that's 5. Repeating that process for B, we now have sides that are 6 and 7.2. Again, add them, divide by 2, 6.6, and that was 5 there. And C, you have 7.2 and 7.8, comes to 15 over 2, 7.5. All right. Add those up, just put in your calculator, and you get a total of 19.1. All right. What does this area represent? The area under a speed time graph is the distance traveled. Okay. And in this particular case, you probably should be specific that it's a time between 1 second and 4 seconds. Okay, right. Let's see what have we got next. 22. All right. Show that these two algebraic fractions can be written in a much simpler form. All right. With one number in there, r, as an integer. Notice that it is a divide by a particular fraction question. All right. And that in fractions, remember, you change the sign to a times and then flip upside down, right? Flip the second fraction. So that's exactly what we've done here. And straight away, just cancelling out some numbers. So you've got the 6 and the 2. Cancelling to leave a 3 at the top. And so that thing simplifies to this first statement here. 3 times 3 x minus 4 times x minus 4. Oh, I should write this, I'm sorry. The x cubed cancels with the x to the 4 there, leaving just an x. So there, just an x, okay, on the bottom. And the other thing I've done, perhaps 2 steps in one, is that 9x squared minus 144, I've taken that as being 3x plus 12 times 3x minus 12, difference of squares. There we go. All right. It's a result that you're expected to recognize. So when we put all that in, this is what we get as our first statement. All right. And now we're going to simplify all of that as much as we can. You've got a 3 in each of those brackets in the denominator. So factorize a 3 out. Okay. And so, for example, just to illustrate that, etc. All right. So factorizing that out, notice how the 3's on top cancel with the 3's on the bottom, and the x minus 4 in the numerator cancels with the x minus 4 in the denominator. And therefore we're left with just 1 over x and x plus 4. All right. And that's your final answer. And therefore, remember, note r is 4. Okay. And one more. This one requires you to know your sine rule. Okay. For triangles, remember a over sine A equals b over sine B, etc. And you also need to know the rule where sine of an angle, call it x, equals sine of 180 minus x. All right. I'm not sure how many of you would remember that in an exam situation, but that is absolutely essential. Trigonometry. All right. So what we're going to do now, okay, we need to prove that AB, this side here, divided by BD is the same as AC is a sort of ratio of DC. All right, so let me just restate that if I said that wrong. AB over BD equals AC over DC. All right, so the ratio of sides in a smaller triangle and then in a larger triangle is equal, is what they're saying. Okay, so using the sine rule stated at the beginning of the question, all right, remember that we have two x's here, so that's x and that's also x. So the angle is split in half, so that total angle would actually be 2x, and that line AD, right, splits that angle in exactly half, which effectively also means that it's cutting line BC in half as well. But using just the angles, right, let's see what we have here. We know that if we label, right, randomly, it doesn't matter what the angle actually is, but if we label the angle ADC as being y, right, then angle ADB, this one, must be 180 minus y. All right. So what we're going to write here is that sine of x, right, using the sine rule as I said, sine of x over DC, right, from the first triangle. How should I label this actually? Let's call that 1 and let's call that 2. So this is from 1 and that's from 2. All right. So sine of x relating to the opposite side. Remember, it's always the side that is opposite the angle. That one there. Okay. Sine x over DC must be the same as sine y over AC. Oh, I do apologize. I just realized I labeled the wrong one. It should be 2 there. Sorry. All right. So using the sine rule for the first triangle, I get the ratio of sides sine x over DC equals sine y over AC. In the second triangle, sine x again, because I've got the same x angle, right, at A. So sine x over the opposite side, which is BD, must equal sine of this angle here, 180 minus y over the opposite side, which is AB. All right. And so we have these two statements. Now, in each case, we have a sine x, all right, like that. And we're using the rule, as stated earlier, that sine of 180 minus y equals the same as sine y, all right? And it's just a stated rule, and you need to know that. Again, if you need a detail on that, you can look at my other trigonometry video, or any details you want, just drop it in the comments and I'll do a shorter explanation if you need it. All right, so what we're now doing is restating both of those equations like this, all right? So sine x and sine y, right, rearranging, and we get a statement for sine y and sine y again. Sine y must equal sine y. Therefore, all we're doing is just putting that statement there, sine y equals sine y, putting the two statements equaling each other, cancel out the sine x's, and you're left with the proof that they want. All right. I think that's a tricky question. Let me know what you think. All right. And that's it. That's the total for the paper. It's taken a little longer than I would have expected, but there's a lot of detail. And those last 4 or 5 questions, particularly the probability ones, I'll just show you again. There's question number 20, and in my opinion, the distribution of the sweets in question number, bear with me, that one there, question number 14. Two of the most difficult questions on that paper. All right. So anyway, if you've lasted all the way to the end here or watching it in patches, thank you so much for watching. And again, if you find any of my videos useful, please do subscribe and comment. I welcome all your comments, any helpful suggestions, and I thank you all for your support. So thanks for watching. Hopefully I will see you in the next video.